my talk before lunch here is going to deal with using summer annuals in grazing systems, and I want to spend just a little bit of time talking about how summer annuals fit in, and then showing you some data that we've been gathering at the Southern Piedmont Center in Virginia over the last few years. And then I kind of end up talking a little bit about how I think summer annuals fit into grazing systems. And there's no right or wrong answers here. It's got to fit into your operation. So this is kind of the idea behind using summer annuals in the grazing system. And we have our cool season grass growth here. This is a typical growth of tall fescue, clover pasture. A hump of growth in the spring, sometimes more than we can use. And then a hump of growth in the fall. Not much going on in the summer months when we talk about cool season grasses, especially as you move a little bit south from here. Remember, that's got the C3 photosynthetic pathway, so it's really temperature limited during the summer months. And where these summer annuals can come in real handy in grazing systems is not to plant the whole farm in them, but plant a portion of the farm that will supply some supplemental grazing during the summer months. And they have some real advantages in terms of quality. They tend to be very productive during the summer months if you get a little bit of rainfall. And the quality tends to be high. So if you have high producing animals, either a dairy grazing herd or you have stocker calves or something that you want to really glean some performance out of, then these summer annuals can be a really good fit in a grazing system. Today I'm going to talk a little bit about some of the summer annual variety testing that we've been doing in Virginia, and we've kind of added in the last several years an interesting twist to that. Talk a little bit about crabgrass. Anybody use crabgrass in here? Boy, look at that. This must be a row cropping area. But I think all of you probably use crabgrass to some point in your pastures. You just don't realize it. And my wife always gets a kick when I talk about crabgrass. Last night I got to the hotel and she sent me a picture from the cover of a Handyman magazine, and it said 10 ways to eradicate crabgrass. And here I am talking about the potential of using it in a grazing system. So, and I love those Scott's commercials. You know, you hear in the spring, you're a better person if you kill the crabgrass in your lawn. And if it wasn't for crabgrass and Bermuda grass in the south side of Virginia, we'd have a lot of really hungry cows. And I want to talk a little bit about some work we're doing with some newer forage sorghum materials, looking at the potential to use the silage systems. And then kind of just summarize the thoughts on summer annuals. So a little bit about some of the variety testing. We've been testing variety since the early 2000s of summer annuals. Those include things like pearl millet, sorghum Sudan grasses, forage sorghums, and Sudan grass hybrids. And recently we've added a twist to this, and that twist is that we started to look at in vitro digestibility of these materials. So in the past, you know, the recommendations have always been choose a good yielding variety that you can get for a decent price and then manage it. And what we're seeing with some of these new materials is really some pretty good advances in digestibility of these materials. So these are the species that we're looking at. And then this is just a little bit about our management. We put down 75 pounds of nitrogen at seeding and then 60 pounds after each harvest of these summer annuals. This is a snapshot of some of the varieties in this trial. This is from 2009. This is the first year we looked at digestibility. So what I did was there was about 30-some varieties in this trial. I took some of the top, some of the middle, and then some of the bottom performing varieties to kind of give you a snapshot of the trial. But what was interesting is that first harvest yield ranged from 3,800 pounds of dry matter up to 6,800 pounds of dry matter, which is a pretty big range in yield at that first harvest. So that was interesting, but then we get the lab results back, and what was even more interesting when we looked at the in vitro digestibility was the digestibility at the first harvest ranged from 54% to 74%. So when I saw those lab results come back, I said, well, certainly that's related to the yield. So the varieties that were more advanced in maturity, we know as the plant matures, forage digestibility goes down. And then we started really looking at the data, and what we saw was that some of the highest yielding varieties in the trial were also the most digestible at that first harvest. So that kind of stimulated my interest a little bit in this relationship between yield and digestibility. So we graphed out the relationship between yield on one axis on the bottom here, and then we looked at the in vitro digestibility of some of this material. And what we found was no clear relationship. It kind of looks like a shotgun on this graph. So what this tells me is that yield and digestibility may not be as closely related as we once thought for some of these newer materials. A lot of these materials that we're testing now have what we call the BMR trait. That's the brown midrib trait, and that's where actually the midrib of that leaf, that thing that goes down the center of the leaf, that's where that midrib is actually a tan or a brown color. And that's a mutation that takes place inside that plant. And that mutation causes lower lignin concentrations in that plant. Lignin is a material in that plant that causes the plant to be less digestible. So not always, but sometimes when we have this brown midrib trait, we have increased digestibility of that plant material. And that's kind of what this graph is showing. So I took all the varieties in this trial and we averaged them for non-midrib, brown midrib trait, and BMR traits. And what we found was about a 5% increase in digestibility just by having the BMR trait in there. So then we broke it out a little bit further, and there's several places in the genome where this BMR trait or this mutation can take place. At the BMR 6 gene, 12, and 18 gene. And depending on what seed company you're dealing with, whatever seed they're selling, is the best BMR, the BMR material. But we didn't really see a big difference whether it was the 6 gene or the 18 gene or the 12 gene. There was no significant differences in digestibility, and they were all higher than the non-BMR materials. What was interesting, even within a non-BMR or these different genes, there were significant ranges in the digestibility averaged over the entire growing season. So we had ranges of over 10% in some cases in digestibility for these different materials. What's this telling us? This is telling us that just because it's BMR doesn't mean that it has increased digestibility. We really need to start looking down at the variety level and looking at digestibility for individual varieties. And this is kind of what I'm trying to get at with this testing program. This is an indexed yield and digestibility graph. So what that means is that 0 here represents the average for the trial for yield on the bottom axis. So if I had a variety that was a 0 in this scale, this would be the average yield for the trial. The same thing for digestibility on this side. A 0 right here represents a average digestibility for the trial. When we draw 2 lines across this graph, we come up with 4 quadrants. And varieties that land in this quadrant have above average digestibility and above average yield. Ones that land here have below average digestibility and below average yield, and that's that bottom left-hand quadrant. These are varieties that we probably want to avoid putting into a grazing system because they're lower in both yield and digestibility. These are the varieties that we really want to target for increased animal performance in grazing systems. These ones that yield consistently higher than the average in dry matter yield and consistently higher than the average in digestibility. And so when we look at some of those varieties over several growing seasons, Extra Graze, that's marketed by Evergreen Seed in Virginia, is one of the ones that yielded for 2 years of the study in that upper right-hand quadrant. These materials from Advanta Seed, 9301, 6501, 22050, sometimes branded by other companies, have yielded above average and had above average digestibilities in 2 years of this trial. What I want you to take home is you've got to ask for this kind of data. This is not data that seed companies want to offer you because it's expensive to do these kind of trials. You have to ask your seed company for this kind of data. And I don't know who handles the Advanta products in this part of the country, Mark. Is it Byron Seeds, maybe? King Agri-Seeds handles them in Virginia, Pennsylvania type area. So and sometimes they'll brand these Advanta products with their own name, so you have to ask for that data too. So just summary, the BMR trait on average increased digestibility. No BMR genes seem to be superior to the other ones in my research. The range and digestibility was great, both within non-BMR and also BMR trait materials. So it's important to look at individual varieties when you're making a choice. So we need to consider both yield and digestibility when selecting or recommending varieties for grazing systems. All right, let's move on a little bit and talk about crabgrass. And crabgrass is pretty well adapted nationwide. And I know my friend John sitting over there cringing because he's in weed control at Ohio State University and me talking about crabgrass and grazing systems. But it's got some advantages. It's a pretty good weed if you're trying to fight it. And that makes it sometimes a pretty good forage crop because it's really an annual, but it acts like a perennial through self-reseeding. So every year it's going to come back from seed, but it's going to be almost like a perennial because it's such a prolific reseeder. And we can double crop this with a winter annual crop like annual ryegrass or some kind of a small grain mixture. And so we have crabgrass in the summer and then a small grain mixture in the winter months and early spring. Has good yield potential, but where it really excels is forage quality. It's much higher than other perennial warm season grasses like Bermuda grass. No prussic acid like the Sorghum Sudan species. And it can accumulate nitrates, but only on really limited circumstances. Believe it or not, that's crabgrass. And that's 60 days after planting it at the research station in Blackstone. This Red River Crabgrass, and yes, you can buy named crabgrass species. There are several on the market. And this is Red River Crabgrass. It's been selected for higher yields, increased leaf blade length, and persistence in grazing systems. This is the response of crabgrass to nitrogen fertilization, and we can see when we hit 305 pounds is when the nitrogen response curve was flat. We'd never ever tell you to apply 305 pounds of nitrogen to crabgrass. Here's where you need to be. Back here around this 75 to 100 pounds of nitrogen is going to give you a good yield response in crabgrass. But the point I want you to take home is that crabgrass responds to some nitrogen fertilization. In terms of forage quality, we've seen in vitro digestibilities, 75 to 90% depending on the stage of the crabgrass growth. We've seen crude protein 6 to 14%. 6% at the end of the growing season when that plant's senescing and dying off. Usually in mid-growing season we're looking at somewhere between 10 and 14% depending on nitrogen fertilization. Dalrymple, who was at the Noble Foundation, did a lot of crabgrass work over the years. And ran a lot of soccer calves over crabgrass pastures. And medium quality crabgrass, he saw on average gains of 1.85 pounds, averaged over a whole bunch of studies over a whole bunch of years. Compared to Bermuda grass, crabgrass yielded 3/4 of a pound more average daily gain. This has got some real potential for high producing animals and maybe even in grazing dairies. I want to change up a little bit and talk a little bit about the potential of forage sorghum for silage. And you're saying, well, I can grow good corn silage. And if you're blessed with good soils and good rainfall and consistent corn silage production in high yields, then maybe that's the way to go. If you're on marginal soils, we have a lot of marginal soils in Virginia and the Piedmont region. They're kind of marginal for corn silage production and kind of drouthy. Maybe you should consider looking at forage sorghum for silage. Let me tell you a little bit about what we did. This picture was taken in 2010, and you can see the response to this plant to drought that we talked about this morning. All the leaves are rolled up. This was a mixture of corn and forage sorghum. And it was a miserable year. It was dry and it was hot, and let me tell you how the corn performed. It germinated, it came out of the ground, it got this tall, and it shot a tassel up, and that was it. It was pretty much done. The sorghum, it looked miserable most of the summer. It just kind of hung around. It was gray, it was curled up, but then it started to rain in August, and that sorghum produced silage, and I'm going to show you the yields in a second. So the drought tolerance of forage sorghum is just much greater than corn. It tends to wait on rain much better than corn will. So what we did in this experiment is we planted corn mixed with forage sorghum, and we had a corn alone, and we had forage sorghum alone, or we had them in a mixture. And we added had a standard rate of corn, then we added 2, 4, 6, or 8 pounds of forage sorghum per acre. And we used a brown midrib brachytic dwarf forage sorghum from Advanta Seed. It's a pretty neat product. In the past, forage sorghums have been real tall and lanky. You know, it could get 10 or 12 feet high. And that makes them real susceptible to lodging, especially when you incorporate the BMR gene, which has less standability, makes the plant have less standability because it has less lignin in it. But this brachytic dwarf gets only about 4 or 5 feet tall. And what they've done is they've shortened the internode length. So instead of having a stalk this far between leaf blades, it's maybe several inches now. So it's leaves just stacked on top of each other. It's a pretty neat product. We applied 100 pounds of nitrogen per acre, and we harvested it when this forage sorghum reached the soft dough stage. And this is the yield we got in 2010. This is adjusted yield. So this is silage yield at 35% dry matter. And essentially we had 5 tons here with our corn alone, and a lot of that tonnage was actually crabgrass. And then we had, as we increased up, we had up to around 10 or 11 tons, maybe 12 tons with the forage sorghum added to that corn mixture. So adding a little bit of forage sorghum really increased the drought tolerance of that mixture. The question is should you plant corn and forage sorghum together? And I don't know. I mean, maybe, but maybe if you're in a droughty area, you should just go with forage sorghum alone. We repeated the experiment in 2011 and again had dry early season conditions and then better moisture later in the growing season. And again, we had a similar corn yield, but we had yields up to around 15 tons of silage per acre with this brachytic dwarf forage sorghum. One of the Achilles heel of forage sorghums in the past has been poor milk production. Not poor, but lower milk production with dairy cows. We think that the brown midrib brachytic dwarf is really maybe a game changer. There's some data out of Iowa that shows similar milk yield to corn when the ration was balanced properly. And that's pretty important. And we've seen some anecdotal evidence in Virginia of dairy farmers who are using some of this brown midrib brachytic dwarf are getting milk yields similar to corn silage. The energy is a little bit different. There's more digestible fiber in the BMR forage sorghum, and then there's more energy from the starch or the ear in the corn silage. One of the things that seed companies often talk about is how much money you can save by using a brachytic dwarf forage sorghum, and a lot of times they say it costs half as much to grow as corn silage. And so I kind of tried to put some numbers to some budgets that we have at Virginia Tech. And what I found was that it did cost less to grow forage sorghum, but it was about 15 or 16% less. It wasn't the half that a lot of companies talk about. Because a lot of the costs are associated with harvest, and they're going to be similar for either corn or forage sorghum grown for silage harvest in a direct cut system. Where we save some money is nitrogen. Forage sorghum tends to be a little bit more efficient at using nitrogen, so we can put a little bit less nitrogen on than corn. But at the end of the day, the difference was not negligible, but it was less than a lot of companies advertise. So about 15, 16, 17% difference in the budget for forage sorghum versus corn. So the question is say one more time. So he wants to know where the magic line is, and I guess I'm going to tell you I don't know. And that's just the truthful answer. But I would say as you get into soils that are where you have a greater incidence of drought stress in corn, that may be where the magic line is. And so if you have soils that will support corn silage production pretty consistently, then probably corn is the way to go. If you have soils that are more droughty, then maybe consider sorghum. But we've seen consistently in this year's corn silage variety trial at the research station of Blackstone, the average yield was 6.5 tons. I mean, it was a tough early summer. Even planted on time, I mean, it was a tough season for corn. We essentially had no ear on that corn. Sorghum planted in the adjacent field yielded about 18 tons. So pretty big difference. And a lot of it has to do with corn if we get moisture at the right growth stages of corn, we can produce a pretty good corn crop. But sorghum is more tolerant to having waiting for that moisture to come than corn. It's not perfect. There's no silver bullets again, but just another tool you may consider using. So this is kind of my take on summer annuals. I think they're a good tool to, a good tool to provide some summer grazing during deficit periods. And they have opportunities in terms of they have pretty quick germination and emergence. They have rapid growth, good productivity and quality, and then flexibility of utilization. What I mean by that, if you plant summer annuals and you decide you got enough grazing, you can harvest them as hay. You can harvest them as dry hay, or you can harvest them as baleage, or you could even chop them and put them in a silo if you needed to. But they give you some opportunities to supply that summer forage. And if you don't have enough summer grazing, then you can graze them. So there's some flexibility there. Challenges are always annual establishment cost. And I think even bigger challenges increase risk of sand failures. Whenever you're establishing an annual crop, you're always fighting against not having enough moisture, having too much moisture, getting things in on time can all be a challenge when you're talking about using annuals. And then limited growth due to drought. Annuals are not a miracle species that are going to grow when there's absolutely no moisture in the ground. But they do provide an opportunity if you can get that crop in and get it established and get that plant up to a certain height. If it gets dry, it's going to wait on moisture. And then you can get some good growth when that rainfall comes. And one of the biggest benefits of having these summer annuals and grazing systems for the summer months is they'll respond to that water when it comes because they have that C4 or that warm season photosynthetic pathway. So this is kind of my overall take on annuals. I think profitable grazing systems are going to be based on perennials that are well adapted, that we can count on that's going to be there, and then supplemented with winter and summer annuals to fill in those deficit periods of the year. And with that, I think I'll just open it up for questions. So the question was, did I plant it for the corn crop or for the forage sorghum crop? And the answer is, I planted it at a time when our producers would plant a late silage planting in the spring. So that was like the last week of May. So it was a little bit late. We like to see corn go in by, say, April 15th. And we planted about a month later than the ideal corn planting time. But it would simulate what a farmer would do for a late planted silage crop. Sometimes it works out for those crops, sometimes it doesn't. We didn't check for nitrates, but it can have a bearing, especially if that stress period comes towards the end of the growth cycle. But nitrates usually occur when plant growth slows. So we'll see a accumulation of nitrates. And really, when that plant growth slows, that's not the ideal time to harvest it. When you really want to harvest this is after the rain comes and that plant is actively growing. And about after a week, it processes those nitrates and turns those into protein again as that metabolism starts back up in the plant. So I think we can avoid a lot of nitrates if we simply time our grazing or our harvest when that plant's actively growing again after a drought stress. I think so. The growing season may be a little bit more compressed here than it is in Virginia or North Carolina, but I think it would persist here. Do you have anybody using Red River Crabgrass in the group that's not afraid to admit it? You didn't get it established? Yeah, it is better adapted to a little bit lighter soil. Yeah. There's only really two named varieties of crabgrass, and they're both pretty similar. You know, Quick and Big has a little bit more upright growth and comes on a little bit faster in the growing season, but you know, I don't know. It seems like crabgrass grows well in crop fields here, so I don't know. Maybe we just need to refine the management practices for pastures. Yeah, boy, you should have seen the look on my farm manager's face when I told him that I wanted to let the Red River Crabgrass go to seed. It was a look of horror. He's like, I want to know how to keep it from going to seed. So it is a prolific reseeder, but the question that Mark was alluding to is how do you manage that the following spring? And ideally you have a small amount of tillage in that system to stimulate that that regeneration of that second crabgrass crop. Sometimes we'll do it in the fall, and sometimes we'll do that tillage in the spring. It seems to work out pretty well for us to do that tillage in the fall and then come in with a small grain in that stand. But crabgrass likes soil disturbance, so it's kind of a species of opportunity. It doesn't grow in a well-managed pasture. It grows where there's a hole in the pasture because it needs about a 6-inch spot to really get established. Sometimes you can take that seed, and that's kind of a seed that will bridge in a drill, and mix it with some soybean meal or some other kind of a carrier to get it to flow through a drill. And hopefully, if you get a reasonable good stand the first time, you won't have to reseed it again for a long, long time. That sounds like a weed nightmare, doesn't it, John? All right. Was there one more question? I was wondering about the... That's a good question. So the question is the BMR trait naturally occurring or transgenic? And it's a naturally occurring trait within the plant. All right. Thank you for your time.